can we predict whether a precipitate will form when a compound is added to solution or when two solutions are mixed? It depends on the solubility of a solute, which is defined as the maximum amount of solute that will dissolve. Chemists refer to substances as soluble, slightly soluble, or insoluble. A substance is said to be soluble if it visibly dissolves when added to water. And if it doesn't dissolve, it is said to be slightly soluble or insoluble. So that means soluble compounds become aqueous and it dissolves to its constituent ions, and insoluble compounds remain a solid or a precipitate in a solution. To help us predict whether a compound is soluble or insoluble, we are gonna go over the solubility rules.
Let's take a look at our solubility table. Our solubility table is split into 4 different columns. The first one tells us that these compounds are soluble. In the first group, Group 1A metals or compounds containing alkaline metal ions are soluble. This consists of lithium, sodium, potassium, rubidium, and cesium. The second column, which labels exceptions, makes it insoluble. In this case, there are no exceptions to this rule. Every time you see a Group 1A metal, that means your compound is always soluble. Looking at the next rows, we see that ammonium, nitrates, bicarbonates, chlorates, and acetates have no exceptions to these rules as well, thus making its compound always soluble. Now, when we move on to something that is halogen, namely chlorine, bromine, and iodine, they are typically soluble with the exception of silver, mercury, and lead. So, whenever we see silver, mercury, or lead attached to a halogen, that makes it insoluble. But if these metals are not attached to a halogen, then we know it would be soluble. The last one in this column is the sulfate, with exceptions of all these metals. All these metals, when attached to sulfate, means it is insoluble. Now we're going to move on to the rules in insoluble compounds. All of these are normally insoluble with a few exceptions. So let's take a look at carbonate, phosphates, chromates, and sulfides. These are typically insoluble, but we are going to have exceptions to that rule that make it soluble. So if we have anything in Group 1A and ammonium attached to these, meaning it is aqueous. If these compounds are not attached to any of the Group 1A metals and ammonium, they are typically insoluble. Lastly, the hydroxides. Whenever it is attached to Group 1A metals and barium, then we know that they are soluble. And if it doesn't have these metals attached to it, then we know that it is insoluble. Now that you have a better understanding of the solubility rules, let's try to predict the solubility of different compounds.
Silver chloride. Let's take a look at the chloride part first. The halides are generally soluble except with silver, lead, and mercury. Silver is an exemption, so it is insoluble. We are then gonna write solid. But now what about potassium hydroxide? The first thing to look at is potassium, which is in Group 1A metals. And those are always soluble. So this is gonna be aqueous. Barium hydroxide. Hydroxide are typically insoluble, but barium is one of the exemptions of hydroxide compounds, so it's gonna be aqueous. Lead iodide. Iodide is generally soluble, but lead is an exemption of the iodide. So lead iodide is gonna be insoluble. So we're gonna write lead iodide as solid. Calcium phosphate. Phosphates are generally soluble except with group 1A metals and ammonium. So calcium is not an exemption. So this is compound is gonna be solid. Barium nitrate. Is it soluble or insoluble? Nitrates are always soluble, so this is gonna be aqueous. Chloride is generally soluble, but mercury is an exception, so this compound is gonna be solid. Acetate is always soluble, so calcium acetate is aqueous.